Hello, everyone. My name is Elisa Baum, and I'm Percona's Director of Product Marketing. We'll begin in just a moment, but first I need to conduct just a bit of housekeeping. Could you please raise your hand using the hand icon located in the GoToWebinar control panel to let me know if you can hear me? Can you guys hear me? Let's see. Okay, great. Thank you for your feedback. I see that you can hear me. Next, during this webinar, you will be on mute, but should you have any questions during the discussion, please enter them in the questions field within the control panel. At the end of the webinar, we will take time to answer as many questions as possible, and questions that aren't addressed will be answered in a follow-up blog entry on Percona's MySQL Performance blog. In addition, a recording of this webinar will be made available to everyone within 48 hours. With that said, I'd like to thank you for joining today's webinar, Putting MySQL Fabric to Use, and it's going to be presented by Percona consultants Fernando Ipar and Martin Arrieta. In addition, our Director of Product Management, Matt Griffin, will be joining us for the questions and answer section of the presentation. With that said, I'll turn the floor over to Martin and Fernando. Go ahead, guys.
Thank you, Elisa. Hello, everybody. I'm Fernando, and Martin is right here with me. Hello. This is the first time we do a webinar together in Percona. I've done them before, but first time I share one, and also the first time that it's going to be mostly just live demos of the product. So please bear with us and be understanding if we have any kind of problems. Well, that said, basically we're going to be having very few slides, just mostly to give an overview of Fabric and its architecture and some concepts. Then we're going to be showing you some resources that you can refer to after the presentation, and that complement the video recording that Elisa was mentioning. And after that, we'll just go straight into live demo, mostly just sharing console and text editor outputs. If you have any questions while we're going, as Elisa said, just type in the panel, and then we'll have a Q&A session near the end. And I'm also have a follow-up blog post on MySQL Performance blog. So let's start with some content for God. Let's start with some glossary of terms that you need to understand before figuring Fabric. Lots of these things already, you probably already know, but we're going to be mentioning how they fit within Fabric or how Fabric talks about them. And Martin is going to be taking the lead now.
Okay. Well, we are going to start with the node. The node for Fabric is just a MySQL instance, so you can have more than one in a server. The group concept, it's a group of nodes, so you can either have more than one node in a box, and more than one group in a box if you have multiple instances. The connector is the way that you have to connect to the Fabric. So it will be the one that in charge of redirect to the write node or to the read node. We are going to explain that a little bit more later. And a host is a server itself. The store, it's a special node where MySQL, Fabric will have the metadata about the cluster and the sharding configuration. And sharding, HA, it's a high availability group. It's about multiple nodes. And so,
just to comment that the group in terms of HA with Fabric, it has one primary and it has 0 or more secondary nodes. It can also have no primaries. For example, when you create a group, well, actually, when you create it, you'll see it in the examples, but the group is empty as expected. And when you add the first node, MySQL Fabric doesn't change the status or anything, so it's also not primary. But the primary concept here is like a node that can take writes, and the secondary is a node that can take reads. There's a third state. There is a spare. A spare is a replication slave of the primary, but it will never be served to client connections. It's just there like RAID spares, for example. The only difference is that unlike RAID, Fabric will not promote a spare automatically if the other node failed. It's there for you to do it. It's just, like a replica that is giving you idle capacity in case it's needed.
Okay, so we already mentioned the HA, which is a high availability group, and basically, yes, that's what Fernando just explained you. And sharding, it's the availability to have to split the database. I mean, it's the sharding concept to split one database or one table in multiple nodes.
And finally, just a short comment in the connector. When we say connector here, we're going to be talking about the Fabric-aware connectors. Those are produced right now by Oracle, and for example, for Python, there's one for PHP, for Java, probably others, but I think those three for sure. And you need this in order to, get the connect to Fabric service that is an XML RPC server, and fetch information on the nodes from a given group, which one is writable, which one is readable, stuff like that. You can connect directly if you want. I mean, if there is no Fabric-aware driver for whatever language you choose, suppose you're programming in Go or Ruby, you can still do it on your own. Like it's just connecting to the XML RPC server and getting the information. I mean, it's not so easy, but it's still doable. So it's not like an exclusive point.
Yeah, and also you can connect directly to each node if you know which role each node it's have, so you can connect directly with using any other connector. Okay, this is the basic setup for HA. So you have one connector, and that connector can access to the primary node and two secondary, as you can see here. The red lines means replication. So the primary is the master of secondary 1 and secondary 2. And both secondary nodes are passive nodes. So you can promote one of those to primary in case that the primary failed, or you can do it manually if you just need it. The connector handles the connections. It's in charge. You can specify to the connector if you need to use a read-only connection and a read-write connection, and the connector will handle that for you. So that's the good thing to use the connector from Fabric, the connector that Fabric use. Because if you connect directly to any node, you will not be able to handle that, to tell, okay, I need a read-write connection or a read-only connection.
Okay, so for sharding, the architecture is similar. A missing item here in the diagrams is the Fabric server itself, the XML RPC daemon that I mentioned before. The workflow basically is a client application requests a connection. You'll see then a source code example later in the webinar, but basically when you put the host name and the port, instead of putting the MySQL server name and 3306 or whatever port you're using, you put the Fabric host name and the port that you're using for that. And so the connector, which is like MySQL normal connector, establishes the connection against the XML RPC server, gets the list of nodes, and then it's all makes transparent to you. And then as you request, as Martin was saying, a read-write or read-only connection, it chooses the appropriate server. And in the case of sharding, you can also, instead of read-write or read-only, you certainly have that because shards are in groups, and groups can also have multiple nodes. We'll see in the next slide. But you instead ask for a given shard, like a table, and then you give the shard key and the value that you're sharding for. With that information, the Fabric-aware connector uses a lookup table and finds the right shard to redirect you. This happens, this connection between the connector and the Fabric XML RPC server happens only once when you establish a new connection. Then the driver has a cache, and it uses that cache for making routing decisions. So you don't have that overhead for every time that you issue a query. We'll see what happens when a connection breaks and all that. In sharding, you have a special group, which is the global group, and then you have the shards, the individual shards. The global group is used for basically two things. One is for schema changes, when the table structure is the same across all shards, including the global group. And if you want to do an alter table or create a new table, whatever, you just run it in the global group. And as you can see from the red lines, the other groups are all replication slaves of the global group. And the other thing that is used for is to store global tables. These are like small tables that you don't need to shard, and you must use from the application. Typically, like configuration tables, things like that. And then the shard groups are basically, when you partition the table, you have, for example, we'll use the salaries table in our examples, and you can have, shard 1 for employees up to ID 25,000, and then shard group from that upward. And connector, just when you specify, you say you want a read-write connection to salaries, and my key is X, and you give a number, for example, 10,000. So with the lookup table and the key that you're giving it, it's the size that you need a read-write connection to shard group 1. Now, the combination of read-write, read-only, and sharding, HA and sharding, is seen here in this diagram. It's essentially the same, except that every group has more than one node. There's a small mistake here that we'll fix. In global group, you should have global node 1 and global node 2. But basically, you can see that now we have replication both intergroup and intergroup. Within the group is used between the primary and the secondaries, and between groups is used between the global and the shards. And so, for example, if the primary node in the global group dies, and the group is set up it's activated in Fabric, we'll see that later in the examples. Fabric takes care of promoting the passive node as a new master and changes replication in the shard groups. So, for example, shard 1 node 1 and shard 2 node 1, which are the primaries for those shards, would be repointed as replicas of the newly promoted node. All of that is done by Fabric transparently, and you don't have to worry about it. So basically, from the application, what you just need to do is you need to request the connections, and you need to be aware that the table is sharded, it's not transparent, and you need to give the shard key on the query also. Fabric is not going to parse the SQL or anything like that. Okay, so now we're going to be briefly mentioning some resources, as we said. There's a GitHub repo there. The slides are going to be made available, so you don't have to write this down now. The repo, it has a vagrant environment, which is what we use today for the tests. So you can reproduce our test or cook your own after. It has a few source code examples that we'll be adding, and we'll also be adding a transcript of the presentation, of the commands that we do, sometime within the next day or two. So you can refer to it and see exactly what we did. And then in MySQL Performance blog, we have a category on MySQL Fabric. We're doing a series of posts on the subject, and you're welcome to join and continue reading there. And finally, you can see both our emails. So if you have any questions beyond what we can answer now or in the blog post, just feel free to write to us, and we'll be happy to help as much as possible. And that, people, is the last slide we'll see today. So let's go. Okay, let's go over the examples, and Martin is going to be starting with the HA. So just a brief explanation. If anybody has trouble seeing, please ask the question, and Elisa or Matt will let us know. But basically, as you can see in the bottom status line, I have a console that's called Vagrant Fabric. That's just the root of the GitHub repo. And then I have a connection to each of the nodes. We have the store, and we have 4 nodes. And so now Martin is going to be starting talking about HA.
Okay. First of all, what we need is to create the schema of the Fabric, and we're going to. Are we already created the setup?
I think so. Let me see. MySQL Fabric. We can test by trying to look for groups.
Basically, this will create all the schemas that Fabric needs on the.
We can do it so you can see if you want. Basically, there's MySQL Fabric. There's some. You can try help manage. I'll give you all the commands. And so
the setup will create the Fabric database and all the tables that it needs. Basically, the tables that Fabric will store the nodes, the sharding, and all the configuration. Okay, and you can use the manage tear down to remove all those databases and tables, and you can recreate it. Okay, and this is what Fernando just did. Okay, so right now we are going to start the service, the MySQL Fabric service.
Yeah, we're using NoHub because there is an option, there is -- daemon to make it start in the background, but in the last release it broke, and so there's an open bug report that's going to be fixed shortly. So, but right now we need to use this workaround of starting with NoHub.
Okay, now we're going to look up for the groups, to list all the groups that are already there. Shouldn't be, okay. We don't have any group yet, so we are going to create one. You can do that with MySQL Fabric group create, and we are going to use HA in our setup. So, okay.
That's a symbolic name, by the way. I mean, we picked it.
Yeah.
It may be confusing, but it's just, you could put, group 1 or whatever. It's not that it instructs Fabric that this is about high availability, just a name.
Yeah, all groups are handled in the same way, either if you use it in Sharding or high availability. Now we are going to add. Before that, let's try to list all the servers that are in that group to see that group is empty. Okay. And now we are going to add 3 nodes to the group. We are going to use a loop here, but it's like execute 3 times the same command with the node 1, 2, and 3. And now, if we list the groups, we are going to see the output. It's not that friendly yet now, but I think it's in the roadmap to improve the output of the commands. But right now, you can see that all the nodes are in secondary mode. Let me highlight you. Okay, you can see that all the 3 nodes are in secondary mode, but all of them are read-only. Okay. This is because we didn't promote the group yet. So that we are going to do now, we're going to tell that we are going to promote this group and we want to start to write on that group. So with this node, you have to,
You see, that's why it's live. It's a proof that it's not recording.
Okay, now we have a HA group and it's promoted. So if we list the servers now, we should be able to see at least one of them in primary mode. Yeah, and it's okay, that's another thing that we also sent to. Okay, we're go ahead.
Oh, because there is another command that is called group health.
Yeah.
It's nice too, but it doesn't, it shows you which is primary, but only the UID. It doesn't show you the host name. So Martin submitted a patch to improve this command so that it works like lookup servers and gives you the host name too. And hopefully it'll get merged in the next release.
Okay, so right now we have the cluster running and the group. We have one primary, which is the node 3, right? Yeah.
Yes.
Okay, and after that we have to
activate. Show the script.
Oh, well, okay, go ahead.
No, that's fine. It's just a quick. We're gonna be doing a quick script that creates a table if needed and then reads from it. But just to give you some information here, basically, remember when we told you today, the configuration is just you connect to the Fabric host itself, And in this case, 100 is the store. This is the port that we put, and this username and password is for the XML RPC server. So this is independent of MySQL. The report errors configuration option here means that if the client finds an error in a server, like a server stops responding or whatever, it reports that to Fabric, so that Fabric, the server itself, can update its table. This part is for the database. So this is the user that is going to be using to connect to MySQL, the password, database, and all that. So basically, as you can see, it's 2 steps. I mean, you give a single configuration, but this information is for the XML RPC server, and this is what you would normally use to connect to MySQL. And then the script is very simple. It just creates the connector. You can see when it establishes the connection, it says the group name. Remember we told you today, you need to specify a group name to connect to an high availability group in cluster, and we are requesting a read-write connection. This is a read-only script, but the reason we are using the read-write is because it's easier to know to which server it's writing. We have multiple replicas, and so it could be one of them at random, so we just wanted to do this. And this is just creating a table, no point to see it now. And then basically you can see that in an infinite loop, it tries to connect. The reason this is here because if there's an error, the connection will be removed and it will be attempt to reconnect, and then runs the query. And the query will just, it's a simple select from the same row all the time just to see that it works. A slight sleep, which is here just so we get a chance to catch it in process list. Otherwise, it's very difficult to see. And the host name, so we can see if the node changed. And so then it's just a loop. And here, if we get an error from the database, you can see that what it does, it sleeps for 1 second. In reality, you'll see when we run it that it takes a bit more, and we're still not sure if that's a problem with Python itself or the driver, but it's somewhere in there. Certainly not MySQL because we looked with TCP dump and it's not on the server side for this. And it reconnects. And you can see it does reset cache. Remember, I told you earlier today that the drivers keep a local cache of all the routing information, so that it doesn't have to go to the XML RPC server every time to make a decision. But obviously, when there is an error in the data in the connection, it means that possibly the cluster status changed, and so you don't want to rely on the cache because it's going to be outdated. So you reset the cache, and that way you force the connector to fetch information from Fabric again. So with that said, now we're going to be running the script, and Martin is going to be talking about some failure cases.
Before that, we have to activate.
Yes, you're right. Thanks.
Fabric by itself does not enable the failure detection. So to do that, we will need to activate the HA group. With this, we are telling to the group to monitor the cluster and see if the primary or any node fail and change the status. Otherwise, it will not. Even if the master fail, it will not change anything until you tell to review it. Okay, so now we're going to run the script.
I'm doing this from my own computer, not from DBM, and basically this is, let me remember the name. Okay, HA read test, and here it goes. Like we said, the connection establishment is slow, but there is. You can see that it's reading from node 3, which is the primary node. We can verify it here in the store, and we see that the primary is here. The primary is node 3, so that much is correct.
Okay, and then we are going to shut down the node 3 in order to verify that Fabric can handle the failover. So we're going to shut down the service, and then we are going to move to the script, and we will see that at some point it will have to recreate the connection. In this point, it's removing it's cleaning up the cache and getting the new information from the Fabric, from the store node, and it will change to the next node, hopefully. Okay, yeah, okay. Now you can see that the node that is reading right now, it's node 1. And if we go to the store node and we show the servers, we will see that the node 1 should be the primary. Okay, it is. So good. And as you can see, you have the node 3 in faulty mode. At this point, the MySQL is stopped, so we are going to start it, and we are going to show you how to recover from a failure. Okay, it started. So as we are going to show again, and we will see that nothing's changed. Okay, still faulty. It's one important thing to mention. We cannot use, when we have to change anything from any server, we cannot use the name. We have to use the UUID. So we're going to put this node in spare node and secondary mode. We cannot do that directly from faulty to secondary. And we are going to show that. Yeah, you can see the error. This is because before that, there is a step in the middle that you have to use, and we have to put the server in spare mode. From that point, let me show you the list, the list of the server again. Yeah. Now you have the server in spare mode. We can, from this point, we can move to secondary mode again. So, yeah. Okay. So we list the server again. This will be, now this server will be able to receive read-only connections. Okay. So
that's just a view. I think that's basically for the bulk of it for HA. We can also, obviously, if it runs out of servers, this connection here on screen zero just dies. We can actually go ahead and do that now, like shutting down all. Right there. And Fabric won't have any candidate node to promote. I'll just say
fail.
I don't have any servers to.
Yeah, we don't have any catch for that, so it will just fail. That's great.
You can see the actual message that Fabric sends back is no MySQL server available for group HA.
Okay, so are we going to restore the class, or are we going to start with sharding?
Well, we can just do one final restore and pick one of them and start MySQL on one of them.
Let's suppose that we lose all the nodes and we want to recover from one, from that, and okay, let's start.
All of them are faulty, but we know that node 1 is actually running, so we can do the same thing again.
Change that to spare, and from there we can do that. We can change to.
Oh, okay. And you see now it failed.
Are you using the UID of? No, you're not using the UID of node 1. Oh yeah.
Yeah. And which one was the last master? Let's see. Node 1 was the last master. That's the one I started. Right, but it's trying it to configure as a slave. So let's see if we can just set it to. I don't think it will let us configure as primary. Yeah. Oh, okay. We can just try to promote. This is the better way, actually. We get the node UID, we promote the group with the slave, and that should hopefully work. Yeah.
It's faulty. Okay, let's start the rest of the. Let's start the rest of the nodes.
Okay. Well, let's see why it's not working. We should be able to add a new. Oh, that's one comment, by the way. In fact, since we're failing, we could, like, for example, go here, node 4, and add this one, and in fact that would work. But there's a problem here, and let's go ahead and have this here. We have the test table that we were reading, and node 4 does not have that. Doesn't even have the database. And when you create a group, or when you add a server to the group, Fabric will not take care of provisioning the node with data. It only changes replication configuration. It doesn't do anything else. So when it promotes a node or when it adds it to the group, it just configures as a slave of the right server, but it does not copy the data. That has to be done manually, and that's why we have not decided to go ahead and promote node 4 as a master. So we'll continue starting up nodes and see if one of them can be promoted. Okay, they're all faulty here. All of them were pre-read, so that's probably why at this point doesn't know what to do. But let's try and promote one of them to spare. Okay, so it worked for node 2. And now we should be able to, that's spare, we can now promote the group now, which should work.
No, you have to move it to second.
You're right. Oh, I can just give it here, and this time it should work. Okay. Now we have a primary, which is node 2, and now we should be able to move the others to spare. But let's see if
let's start the script again and see if
the script should be able to connect meanwhile. Okay, so it's running, and let's see if we can go ahead and set the others as spare this time. Yes, and finally this one. Well, actually, let's go ahead and now say secondary.
Okay.
And so we're back at the same situation with one primary, two secondaries, and the script just working okay. So remember here, I guess the important part is that the HA parts of Fabric only manage replication, and Fabric is also aware of which node is read-write, which isn't. The secondaries are actually read-only. Like if we go, for example, node 1. If we go to node 1 now, it will be read-only. So as long as you stick to like same practices within users and don't grant super happily, your data should be mostly safe. And yeah, so finishing that again, it won't provision the servers with data. You have to do it yourself right now. So it's not like, for example, XRB cluster when you have the SSD, and if you have a node joining the cluster, it will get provisioned automatically. That won't happen with Fabric. You need to take care of putting data on the server, and then you can use Fabric to manage replication. Okay, so let's stop this one, and we'll move on to some sharding example. Before that, in the repo, we have a read cluster script. This is just to save us the provisioning time. I mean, we could do background and destroy and background up, but that will have to reinstall the packets and all that. And so this just basically overwrites all the instances. And while this happens, I can tell you the 4 nodes that we see there, each has 2 MySQL instances, one on the standard port 3306 and one on 13306. The reason we did it is so that we could mix sharding with HA, which is something that we're gonna try and do today. Yeah.
There is one important thing that we mentioned in our blog post, but not here. That's all Fabric will need MySQL 5.6 and 5.6.10 and after that, because it will use the GTID for the replication. So that's a high requirement. So there's no way to run Fabric without GTID.
Very good comment. We totally forgot. We've been doing this series and all that. We assume people would be familiar with it, but it's okay. Yeah.
Yeah, I would strongly recommend you, if you are interested in Fabric, to read the blog post, because we are explaining in more detail some of the steps that we are covering here.
Okay, and so for sharding, it's similarly to the HA. And in fact, here's the thing. So you have groups, just like in HA, and groups can have 1 or more nodes, and then you can assign a shard to a group. So, but let's start slowly and let's create a few groups. Actually, let's 3 groups. A global, if we remember the slide that was here, the simple one is the same. I'm going to create a global group and 2 shards. In this case, I'm going to be sharding a salaries table, so I'll be creating that. Let me just remember the global group in sharding is there to have the schema of all the tables, even though the sharded table will be empty here, and to have global tables, which are tables that are small and you need them present on every server. And the shards will all be replication slaves of the global group. This is at the high level. At the lower level, the primary from each shard group is going to be a replication slave from the primary on the global group. Let's create a couple of groups. Okay, now let's add some servers. Let's make only the global, so I don't want to waste a lot of time, but let's add 2 servers to the global group. You just specify the node and hostname or IP and the port, and gonna be adding this. Okay, and actually let's go ahead and promote it. And activate it. So if you recall from the previous example, this means that right now we should have a primary node in the global salaries global group. And if it should fail, Fabric will on its own promote the secondary to a primary. Let's see how it is.
At this point, it's exactly the same of the previous example. We are it's just a group and an HA group, like the same as we did before. We didn't add any sharding to this part yet.
Yeah, let me add just one node for each of the shards. Let's go with node 3. And okay, and I need to promote them because remember, otherwise, even if it has a single node, by default it will be secondary. So okay, so we're pretty much ready to go now, and we start with the actual definition. We're gonna create a sharding definition. You can see the command here, by the way. It lists all the commands for sharding, and what we're gonna be using is this one. Okay, and so we're gonna be doing a range sharding, range-based sharding. Fabric right now supports 2 kinds of sharding, range and hash. From what we can see and what we haven't seen in tests, hash is basically a range over the MD5 of the shard key. So we need to do some more tests, which we're doing for our next blog post, but we're not sure how good that will be to distribute the values evenly across the shard. So right now, I think range is the best approach. You can see that you create a definition in the global group. Okay, right, it's no name or anything, it's just that, and it's on. And then let's add a table to the sharding definition. This one here, this is the sharding definition. So it sounds like magic. It's just that it's not very user friendly yet. Like if I had created a second one here on another group, that would be 2 and on and on. And so here, when I say 1, I'm actually meaning this range definition that I created in the salaries global group. And I'm giving a database and table name, and I give it a shard key. Now, the interesting thing is that, okay, I'm going to create it here. And right now, let's look up again MySQL Fabric group, look up servers, global. And we can see that the primary, for example, is node 1. Okay, let's go to node 1. There is no employees database here, even though, I just did this. This is all to say that this is symbolic. It's a routing table, but, if I go and try and use it now before creating the table, obviously it will just fail. So again, just like with HA, Fabric will not provision data for the server. You have to do that all on your own. This is just like, it's giving you, I like to see it like implementing like best practices, both in HA and in sharding, so that you do it in a good, consistent way. Usually like large companies will already have their own solution for this. But if you're starting from scratch and you think you're going to be needing sharding, I think it could be like a sane approach to use these instead. And so now let's define the actual shards. And we go and we are, again, shard 1 is this one is the same here. If I had added another table here, it would be 2 and on and on. And now we give it a single string that basically lists shard group / the lower limit or the lower bound for keys. So for example, group salaries 1 will get any salaries where emp no is 1 or greater, and the same here, greater or equal to 25,000. And we already enabled this. Okay, and there it is. So now we gotta go and create a table. I told you it's not there, and I'll do this manually on the primary and for the global group. Okay, so that's again node 1 3306. So let's go to node 1, and actually I think I have this here, so I don't have to. This is the file that we're gonna be uploading to GitHub when we're done. It's just that we're gonna be here giving you more examples. So I just copy and paste here. Okay, so now as a safety check, let's go and see Fabric group lookup servers for salaries 1. And we have a primary which is node 3. And so let's go to node 3. And you can see that now employees got created. This got here because node 3, sorry, is a slave of the primary node on the, oh, your keyword has page up. Good. I'm used to working on a small keyword and I forgot about command B or whatever it is. So you can see it's node 1 on 3306, which if we go back here, we see Salaries Global. Node 1 3306 is the primary for Salaries Global. So like I said, this is all done by Fabric, and we can actually, since we let's start running a script first, and then I'll show you how we can kill the primary in the global group, and Fabric will hopefully take care of everything so that it continues to work. We're going to be doing a similar script. This is one that randomly inserts data into salaries. This part is exactly the same as the other one, and then it just inserts, and the reason it's random and I do it with these ranges is so that eventually data will end up into the different charts. So I'll start running it and we'll see how it goes. Okay, so again, there's small slips that we added there to make it traceable, but let's let it run for a bit and we'll check. Yeah. And let's look at this here. If it doesn't go ahead, we'll have to continue, but I think it should work. It's the same as the other and it was working. Let's see if it's connecting somewhere or not. For example, the global. Okay, no, it's not connected to the global. Yeah, it is here. This one is a connection that should be here. Oh, you know what? Yeah, I didn't create a user. That's a good thing. Let me go back to the script and see what it expects. App user with no password. Okay, so I'll go back to the global node and I grant select.
No, it's
on. Please resist the temptation to grant all, even in a live demo. I'd rather, be slower than but safe. Let's see, it should work now. Well, I will try to reconnect again. Okay, it's connected. So it basically prints a timestamp and then the key. Okay, this is great because actually each one of these should have gone to a different chart. So let's once again look at the salaries 1 and then salaries 2. So I want to be looking at node 3 for salaries 1 and node 4 for salaries 2. So I go to node 3 and I do like select there's 2, and let's run the same on node 4. There's 6. So you can see that it's starting to spread the data among the two nodes. And so let's go ahead and before as the last test, and because we're approaching the finish time, I want to go ahead and kill the primary on the global group. And here's the output from the server list, and the primary is node 1. So let's go to node 1 and shut down MySQL div there. Let's actually, okay. We can see that it promoted node 2. The script is still working, but we're probably not using the primary. But the interesting part here is, for example, we go here. You can see Fabric took care of repointing the primaries on each shard to the newly promoted master on the global group. So that's something we don't really have to worry about. So this is a combination of, of sharding and HA. You can use Fabric to scale horizontally by sharding your tables, but at the same time you can grant some level of HA to every individual shard, but having a group and say 2 or whatever number of servers per shard. And you can also like scale reads on individual shards the same way, because if we go back to the code example, again, we are writing here, so we are asking for a read-write connection. You have a mode underscore read only, and if you ask for that and you have multiple secondaries, it will be split among them. So you can scale reads that way with Fabric. And so I guess as a wrap up for these examples, one more thing, the connectors part, like we said, officially it's PHP, it's Java and Python. Okay, with the Java connector, I was not able to use it. I have an open bug report in it. It just throws an exception. And the MySQL is supposed to be working. I got a request from a reader from MySQL Performance blog about an example in PHP, which I'm going to work on. But the documentation is still very green, and I have not had a lot of time. So that's why the examples have been in Python now. And the whole project is very promising. Some parts are a bit rough yet. I think HA is way more mature, like really, it's pretty much usable. I mean, I think if you're on 5.6 already using GTID, and I would rather start up with Fabric than with anything older, like MMM or all the others, because it's not just that Fabric is a new code base, it's just that, GTID I think helps a lot. I mean, just making sure that you have kind of like sane promotion and failover in MySQL before GTID is complicated. And in terms of sharding, I think it's green, it's looking good, but some things are missing. For example, there's no way to guarantee that you write data to the right shard all the time. I think you can get confusing. I mean, that's just a limitation of MySQL. Like if you end up somehow connected to the wrong server, you can still write to it, and you'll end up with inconsistencies. And there's no support right now, for example, to cross-shard queries. Like if you want to do a join across different shards, you have to do it at the application level, or you gotta use something else, like for example, a shard query, but not just Fabric. It's not for that. It's mostly, I think, geared to simple scale-out solutions using, sharding, but that's about it. And well, at this time, I think we just pass it on to Matt for the Q&A, and we hope you enjoy the presentation.
Great, thanks guys. Really appreciate it. So questions are coming in. Thank you, audience members, for submitting your questions. Got a bunch, and just a reminder, anything that we don't get to, there will be a follow-up blog post where we'll get to your questions and all of the slides, as well as the link to the GitHub project to do some of these samples yourself, will be made available to you after today's presentation. But let's begin. So y'all spoke about the dependency on 5.6 and GTID. Just real quick, can you give an overview of what is GTID and how it relates to Fabric?
Yeah, sure. That's also a great question. Like Martin talking about that requirement, a problem that I sometimes forgot. It stands for Global Transaction ID, and that's supported since 5.6.10. Right?
No, yeah, it was before, but
okay. And there is an alternative implementation in MariaDB, for example. And what it means is lets you identify replication events uniquely across a set of servers. Before that, the traditional way to repoint a replica was by using 2 coordinates, a master file name and a position within that file name, and you identify statements or events in a binary log by a server ID. But there was no guarantee that that was unique. The GTID that gives you a unique identifier for every event across a set of servers. And beyond that, it makes managing replication much easier, usually. Again, it's relatively new compared to the old style of managing replication, so I'm sure some rough edges will come up. But in terms of HA solutions like Fabric, it's evidently from looking at source code and the behavior of Fabric from previous systems like say MMM, as I mentioned, it was madness. And so I think ShitID helps a lot to make this possible.
Okay, great, thank you. We have a few questions about failover scenarios, and we've talked about that internally about the failovers and the single points of failure. So can you kind of share a little more information about failover scenarios and how Fabric behaves when a failover issue happens?
Yes, as we saw from the examples, basically, if you activate it, you need to have it activated, and you need a configuration setting that it is enabled in all our boxes in the background environment. Let me look at this here. Let's go to the MySQL Fabric configuration file, and here, failure tracking, failover interval. I think, I remember by heart, but this comes on 0 by default. In that way, Fabric will not do the automatic failover. If you put it on any number greater than that, and you activate the group, if Fabric detects a failure, it promotes an available node if one is available. And when I say Fabric detects, that's because let's go back to one of the nodes, for example, here. Why shut it down? Yeah, let's go to another one. There are connections from Fabric, not just from slaves, this is a replication, but also Fabric. The XML RPC daemon connects to all the servers that it manages, and it sort of keeps an eye on them. And if you activate the group, if it detects any kind of failure, it takes an appropriate action. If the failure is detected on a primary node, what happens is that Fabric will look at the list of secondary nodes, and it will pick up the best candidate for promotion, taking into account like how behind the recent replication and things like that. In our test, it works pretty good. We've done this even with some load on the servers, and it works okay. And there's only one gotcha, that this XML RPC server can become a single point of failure, but it's not like as scary as it sounds. Basically, this server, as we mentioned, is used only on 2 times. When you establish a new connection and when a decision on the status of the cluster has to be made, like if the primary fails and somebody else has to be promoted. If the daemon is down when any of those happen, the cluster is like unusable. So, but if the daemon goes down and you have like a connection pool, so you have thousands of people already connected and everything is okay, nothing happens. It's only when you need to make a change. So I think it's a single point of failure, but you can just same monitoring practices can let you can just have a spare node just in case. Also, it's important to note the Oracle people have said this directly. The store node is storage engine agnostic, so a good suggestion is to run a small MySQL cluster instances to provide HA for that data. In which case, all you need to do to give HA to the Fabric service is have like 2 instances of the XML RPC server and just that, because the backend would take writes on any node. So again, it's a single point of failure, but only when you need to establish new connections or when the cluster state changed. I guess in a way it's similar to the management node in MySQL cluster. If it goes down and something changes, then you're in a bad position. But if it goes down and everything is fine, you won't notice and you can bring it up down in tranquility.
Great, thank you. This question came up earlier in the slides about is replication lag a problem and how do you avoid replication lag? And then as a related question, are there any benchmark stats available around Fabric?
We don't have any benchmark about it, and no, there is no check that Fabric do to set like a node in fail mode or whatever because of the lag. And as far as I know, and Fernando, I think that there is nothing about it, and that's actually a good thing a good request to make them.
Yeah, I mean they're very open for this, so if you can just file a bug request and it should get as a feature request, I think it's a good idea. But yeah, right now you have all the problems in, let's say, simple rewrite splitting. You could end up reading stale data and things like that. So you need to implement in the application logic any checks to make sure that you're not reading stale data.
Great. For the use cases of Fabric, y'all spoke about some scenarios, but do you see Fabric being useful in scenarios of working with big data?
Yeah, we don't see. Oh, well, actually, here's the thing. In terms of HA, yes, I don't see any problem. Like we said, you need to take care of yourself of provisioning the new servers with data, but you could use, for example, extra backup to get a quick, or are they way quicker than MySQL dump copy and all that. In terms of sharding, I'd be more careful because right now, for example, some shard operations we were not able to do in the live demo because we ran out of time, but you can see there. Okay, you will put it in GitHub, the examples. You can split a shard. For example, you can decide that a shard is growing too big and split it in two and move part of it to another group. You can move a shard, for example, if the server that is running on it's reaching its limits and you provision a new bigger machine. But all of that right now is done with MySQL dump and then MySQL. So that's a well-known fact that MySQL dump does not scale well with size, and MySQL is even worse. Which I mean is that MySQL to load a MySQL dump backup takes like exponentially longer when your data set grows. So that would be a concern for me right now. But like I said, the sharding part is green and it's growing. From what we were able to see, the code is modular. It's more designed like a framework than a closed-end system. So it should be reasonably easy for somebody with some basic Python knowledge to, change the behavior or extend it so that you can use this, for example, extra backup to do this, shard split and shard move. And in that case, I don't see any reason why it shouldn't work with big data.
Okay. And does sharding require any kind of application coding changes to interact with Fabric, or should DBAs considering implementing this sit with their developers and architects to understand the tables, their usage, and plan how they will implement sharding?
Yeah, in order to use sharding, you will have to know the primary key that you are using to split the shards, and you will have to use that primary key in the connector. Let me show you the script that we have, because right here we have the example. Yeah, the key. There you have the table and the key that you are going to use for split the shard. So yes, it will require some modifications in your code, and especially you will need to use the Fabric connector in order to use it.
So is it best for would it be best for the implementation of that be done hand in hand with your developers to ensure that any changes to the code will be made in the right ways?
Yes, I think development involvement is very important here. I mean, I don't think a DBA on its own could do this because it's not transparent. So the application has to be aware that there is a sharding scheme behind and how it works.
Also, there is a limitation about the cross showing between the shards. So it's important that the developers be aware of this, because you cannot use joins in the splitted table, because, well, at least no on the whole table. So yeah, that's another thing that the developers must be aware.
Okay, one more question, and then we'll wrap up. Can we say that MySQL Fabric is a good HA replacement for removing the usage of VIPs?
For what? Sorry, I didn't get.
Can we say that MySQL Fabric is a good HA replacement or alternative for VIPs, virtual IPs?
Oh, okay, yeah. So I think I don't see it as a replacement itself. Like it can be complementary. I mean, the VIP itself is it's not a way to manage HA. It's just part of how you manage it. Like, for example, you can decide that the primary node, you can decide to make the primary node known to your clients by DNS records, by a virtual IP, by some proxy like HA proxy. I think that's kind of independent of how you manage the servers beyond there. So below, sorry. So I think it's complementary. Right now, Fabric has no support for virtual IPs, but again, like I said, it's extensible, and I know that they are aware of that, and they probably will be including that. But I don't see the two things as one in opposition to the other. They're more like a complementary things.
Great, great. That's all the time we have for questions. There are many more questions, and I apologize for not having the time to get to the questions. We will follow up with a blog post on the MySQL Performance blog with answers to these questions. And Martin and Fernando, thank you so much for your time, and audience, thank you for your time. We'll pass it over to Elisa to wrap up.
Hi, guys. Thank you. Great job. Love those demos. Okay, so just want to call your attention, audience, to a couple of webinars that are very related to the topics discussed today. On August 27th, we're doing using MySQL Global Transaction IDs in production. So come learn more about that. And then on September 24th, we're doing something on sharding. We're going to be doing a webinar called How to Scale Big Data Applications Using MySQL Sharding. So very related to what we talked about today. And we would love to see you in the future webinars. I will get a recording of this to everybody within the next 48 hours. And with that said, thank you again for joining us, and have a wonderful day, morning, evening, wherever you're calling in from. Take care.
Thank you, everyone, for attending. Bye.
Bye-bye.